Alrighty, everyone, welcome back to the Azure podcast. This is episode number 371 on cloud native machine learning. We have Saurya with us today. I believe I pronounced his name right. We'll give him an opportunity to correct me if I'm wrong. But we're going to cover a lot today in terms of updates, and then we're going to pass it over to him to introduce himself and tell us a little bit about kind of some of the efforts around machine learning and the way that it's progressing on Azure. So I'll pass it over to the team for some updates. And by the way, on the call with me today, Kale, Evan, and Cynthia.
I can't unmute myself. I have two updates that I wanted to share. The first one is on Microsoft Power FX. It is the open source low code programming language. If you use Excel and if you use formulas, you already know what it is. It's created on the foundation of a lot of the languages you use in Excel already. There's right now integration with Azure services, which is very exciting. You can use Visual Studio Code, you can use GitHub, you can use Azure DevOps along with Power FX. There's also connector integration. If you want to create custom API connectors with JavaScript, C#, and there's also some guardrails around using Dataverse to govern your data. So that's really cool. It's now in public preview. And the other thing I wanted to share is the general availability for Azure Monitor for Windows Virtual Desktop. So now you're able to see from a more macro perspective of the health of all of the WVD that you've deployed in your environment. And I think over to Kale.
Yeah, before you go, I'm kind of curious, and maybe we can offline this, but I'm curious how Power FX kind of goes into the low code with Power Apps, and then I'm thinking connectors, I'm thinking like custom logic app connectors. I don't know, I'll have to look into this because I'm not Excel savvy at all. But
yeah, it looks really cool. It's on my list of things to go play with. I mean, it looks like, it feels like you're writing formulas, cells, rows, all that kind of stuff. It's really neat.
Interesting. Okay.
Cool. Yeah, I got 4 quick ones here today. The first one is an announcement about mainly for enterprise around Oracle WebLogic. So there was a partnership announced a while back, a few years back actually, with Oracle. I think it was particularly around the databases at that point, but obviously people are running these business applications using this huge platform called WebLogic that's been around forever. I remember working with WebLogic a long time ago, probably at least 15 years ago, maybe. It's pretty cemented in enterprise. But anyway, there's a virtual machine offering for this now. And basically, has all the stuff up there normal. It's a bring your own license kind of thing. So you can do that, but it's like right as part of our marketplace. So it's very easy for you to spin those up, pick the right versions of JDK, WebLogic you want to run, and you're off to the races. So that's pretty cool. Couple other things. One was these are kind of like awards things. So Microsoft was named as a leader by Forrester Wave for the functions as a server platform category, which was super cool. So as Cynthia just talked about, these low code solutions, behind that, a lot of those are Azure Functions, which is a serverless platform that powers a lot of the stuff that's in Azure that does sort of low code stuff from the back end. And this is a super cool, kind of award to win. So basically kind of cementing, Microsoft as a preferred platform or a popular platform for building those serverless apps. The 2 other ones I have are related, and this is work with a colleague here at Microsoft. His name's York Rhodes. I've been working with him for a long time in the blockchain space. I used to be part of blockchain engineering, actually. But he since has moved to the cloud supply chain, so the Azure supply chain. And he has a nice article up here about how we're using Azure and blockchain together to build a new generation of what supply chain is for traceability, predictability, cost savings, all those kind of things. And then the associated article to that was Gartner had announced their supply chain winners for 2021, and Microsoft won a bunch of awards. One of them was this Technical Innovation Award for using blockchain to save upwards of $50 million as part of this blockchain effort. So pretty cool stuff. To give him a shout out because it's neat stuff built on top of Azure.
Yeah, I do have one more update I want to throw in here. So for those of you who have heard me mouth vomit or word vomit around Dapper for like the past few months, yeah, I think it's word vomit, not mouth vomit. That's okay. But anywho, so Dapper actually got proposed as a CNCF project. So like they have, the various levels of incubation, and you can move through the phases. And so we put in basically a proposal to include that in the CNCF as an incubating project, I believe. And so that's really exciting just with the recent Dapper 1.0 release in February. So definitely keep a lookout for that. Just some other updates in that space. Brigade 2 recently was launched. So it's another open source project that, Microsoft has helped invest in. And so definitely take a look at Brigade if you're interested in learning about some of our open source efforts. But now I think now I think we'll pass it over to Saurya just to introduce himself, talk a little bit about the team that he's here to represent and some of the work that he does at Microsoft around machine learning.
Thanks, Kendall. So my name is Saurya Das. I work in the Azure Machine Learning team. I'm a product manager and I focus on the hybrid strategy and Kubernetes. I've been with the team for a year. Before that, started the whole containers initiative at Microsoft Containers, building Azure Container Services, evolving that to Azure Kubernetes Services. And then, right now I'm just working on doing machine learning, obviously on Kubernetes, because I know nothing else. So yeah, I can talk about, what we are working on here in the machine learning org. Over the last few years, we've seen this whole shift of customers from running on PaaS or IaaS to running on Kubernetes because they want to be cloud agnostic. They want no vendor lock-in. They've got their own hardware assets on-prem, and installing Kubernetes makes it easy for them. So to build one set of apps that can run anywhere. And that is why we built Azure Arc for Kubernetes. So you have a single pane of glass to view all your AKS assets and your on-prem assets, Kubernetes assets. It could be also Kubernetes assets in the cloud, other clouds like VMware Tanzu or Rancher. It could be GKE or even our Azure Stacks, which host AKS Engine today. So we thought, okay, now you can see all of your Kubernetes assets in one place. What more can we do? So this is where Azure Machine Learning came into picture. You got a single pane of glass to centrally govern, monitor, apply policies, do security boundaries. But what first? Which one is going to be the first class Azure service to run on top of these? So that is where we built this cool connector that can run natively on your Kubernetes cluster, and then Azure Machine Learning can deploy training jobs on that cluster. So we want you to use the excess Kubernetes capacity that you have in the cloud or on-prem, and you want to utilize it to run machine learning training jobs. So yeah, that is the whole idea. And the whole, one of the things that we focused on is like you've got in the machine learning world, you have data scientists and there are IT operators. We obviously don't want data scientists to learn Kubernetes. Kubernetes has a sort of a steep learning curve. So we've tried to keep that boundaries separate. We allow you to, with the IT operators and enterprise orgs who've learned Kubernetes and are well aware of it, to kind of slice dice their cluster, set it up for their data scientists. And data scientists, they run Jupyter notebooks, and so we make sure that they make minimalistic changes to these Jupyter notebooks. In fact, the only thing that you probably need to change is the compute target that you are now running against. So previously, in Azure Machine Learning, we have a managed service called compute clusters, and you would target training jobs there. But now you have this additional, compute offering that you can target. So the way we see it as, computes as managed compute and unmanaged compute. So if you don't care about, if your company hasn't made a bet on Kubernetes, you are better off using, standard compute clusters, because standard API, you run the jobs, you pay for what you use, and you don't care about, patching the infrastructure or keeping up with upgrades and all that. But on the other hand, if you've made bets on Kubernetes, you have OpenShift and whatnot, you like to be the cool guy who wants to do Kubernetes, then this is totally right up your alley. And the experience is consistent across the cloud and on-prem.
So with the compute, so with the compute, is that a lot of times when running machine learning or these kind of jobs, they use GPUs or some sort of other kind of like more exotic kind of compute. Is this like supported in this? Is that normal, or is this just like using general CPU type models?
With AKS, you can get NC series, right? The NC series, ND series GPUs. We know that a lot of our customers have, common with NVIDIA, and so they have lots of DGX clusters. So imagine installing, an open source Kubernetes version and bringing it through Azure Arc. So you can target either. So run a training job here, run a training job there, wherever there is excess capacity. The kind of skew, it gives you a lot of flexibility though. Like with managed compute, you have these specific skews, but with Kubernetes, you can just go whatever you want, right? Like you just said, it just democratizes infrastructure.
So I want to make sure, I think there was something really, really key about what you were saying earlier about the managed versus unmanaged compute. I want to make sure I understood it. So even though it seems sort of on the first pass that by moving away from the managed ML service, you're taking a step back by putting this onto Kubernetes, what you're giving somebody back is the ability to now deploy to any environment that has Kubernetes, right? Yep. That's sort of the ML stuff really isn't changing when we're talking about the center. You're giving people the flexibility to run it on stack or on-prem or in OpenShift. Like that's the goal here.
That is the key value. We are not trying to reinvent machine learning at all.
Okay.
I mean, at Microsoft, obviously, we have a lot of learnings. We have a lot of large customers like Bing, Office. We have tremendous amount of learning that you cannot realistically gain unless you run at that scale. But none of that applies to customers here. They are free to use any frameworks they want, like PyTorch, TensorFlow, Scikit or MPI, and just run. We are not telling you how to do machine learning. We are telling you that there's an optional Kubernetes cluster that you can target now.
You're just sort of taking all the effort and complexity out of building your compute stuff at that point, but without tying you into the managed compute that we have, managed service that we have. Great. No, that's awesome. It sounds sounds counterintuitive at first, but now that I get it, that sounds great.
Yeah, we want to meet customers where they are, like your choice. That has been the philosophy of Azure for the last few years, and we want to keep up with it.
I'm curious, kind of following up on that, when the customer has now multiple places where they can run machine learning, are there considerations where running something on-prem is more beneficial versus running something in the cloud, or are there additional considerations they should think about when it's now spread across different environments?
Yes, so definitely. So there are obviously like running a cluster in the cloud and being close to you has network implications, bandwidth implications, whereas running on-prem, connecting over a VPN or any other sort has, again, those restrictions. But it largely depends on use cases. Most of our customers that we see fall into largely 4 broad categories. There are customers who want to use just cloud compute. They have made a bet on AKS as their infrastructure, so they want to use AKS. So super light integration, you can get started by installing the agent in 5 minutes, use excess capacity. The second one is you've got the same amount of capacity on-prem that you are just sitting idle. You want to use that. So install the agent, Arc agent, bring it to Azure, connect to AML, and you're all set. The third and fourth use cases become really useful. That's when you've got all these FSI customers, financial services customers, who cannot bring data to the cloud or cannot bring compute to the cloud. They want to do fraud detection, or media companies who want to process media. They cannot copy the data over to the cloud. They have to be on-prem. So we allow them to kind of allow Azure Machine Learning to talk to their clusters to keep data on-prem while maintaining all the security boundaries. So those are some of the use cases that we see. And there is a unique case of where I want to keep data on-prem, but I want to use scale in the cloud, because the amount of SKUs Azure provides, the amount of regions that Azure provides is huge. It's quite broad, and that choice, even if you try to get that many SKUs, you wouldn't be able to like think about NVIDIA, how many SKUs they have, how many they are going to come up in the future. So they want to use scale in the cloud and just have data on-prem. So when a job runs in the cloud, it mounts data onto the job. It is ephemeral. It doesn't persist in the data inside on the disks inside the cloud. It does a job and then just goes away. So those are some of the use cases that we see. Kendall, you have a question.
Yeah, so I was going to add in something too. I know, Kale, you had asked about the GPU, the GPU compute nodes and stuff like that. I was just going to say there is like an update in AKS that's kind of like on the way, essentially, where we have these GPU specialized images that essentially like come packed with the NVIDIA device plugin. Because traditionally, if you want to use GPU nodes, you'd have to go in and basically apply a daemon set, which is going to be a pod that runs on every single node in your cluster. And so it's just, we're optimizing the GPU image experience kind of. So that's just something worth calling out because it's been in the release notes for like a couple months that's going to be the default.
It's fantastic.
But yeah, I was going to ask you about the integration with things like AKS. So I think we talked about this, or maybe I remember you speaking on this. When a customer comes in to provision their machine learning job, it's not going to auto create an AKS cluster, right? It's you create an AKS cluster, you already have it, you bring the cluster. Is that the case?
Yep, that is an important distinction. So you bring your own cluster. You are responsible for managing the life cycle of your cluster. So think, for example, AKS. AKS is the management of AKS, the lifecycle of the cluster is distributed between the AKS team, Azure, and the customer. We provide you bells and whistles to upgrade every 3 months. We make the process easier. There's a bunch of configurations that you can do, apply patches. And like Kendall just pointed out, there was a day when you had to manually install your NVIDIA drivers. Now we have made it easy by installing them out of the box, depending on the NVIDIA GPU that you're using. So it's kind of you manage Kubernetes clusters. What we are responsible for is the agent we deploy on the cluster and making sure that is up and running and making sure that you can deploy training jobs seamlessly across clusters if you have resources.
Yeah, one question with that. So, like, I'm not familiar with that last piece you were talking about, where you actually deploy the agent and schedule these jobs. And maybe this is a dumb question, but I'll just ask it anyway. If I had my own cluster, my own AKS cluster, and then I get this all configured, what kind of like exposure do I have to give like my developers or my analysts? Do I have to like open up a whole VNet? Like, what kind of network connectivity? Or is it like, well, it's just standard Azure, so whatever their connectivity is to get into this port, that's it,
So it depends, right? So if you look at AKS, there are various ways to access the cluster. You can RBAC it to give specific permissions to specific namespaces with service accounts, roles, and role bindings, and then we can either use that to deploy the jobs, the training jobs, or for on-prem clusters specifically. Also, what we've done is we've integrated with Azure Relay. So we no longer have access to your kube config. We have provided this relay that has a trust boundary with the Azure Machine Learning control plane, and we just you submit a job from the Azure Machine Learning APIs. We go line them up in these in the relay, and then from inside the cluster, the kubelet and the API server are able to pick these jobs and deploy them. So that is the only outbound proxy connection that you need to maintain, and we ensure that you are within the security boundaries, and we don't randomly go access your cluster. We just want to make sure we don't have access to that level. And all of this is actually strictly enforced by Azure's product launch readiness boundaries that we have, where every product in Azure has to go through certain criteria at every milestone. Public preview, private preview, you must meet this criteria. You must define whether you're using private endpoints, managed identities. Azure has just made sure that no individual service can break these boundaries, especially in the light of all these security hassles we've had over the last few months.
For just taking one step back for our listeners, RBAC is role-based access control.
Yep, that's good.
And question for you, sorry, in terms of orchestration, if I know that I want to run this machine learning job, but I don't know when my clusters will have availability, is there a way that I can automate this process and say, like, when it does have capacity, run it there? Or if it doesn't have capacity on my on-prem clusters, can I run it on the cloud instead?
So that is something. So So we are not scheduling your jobs. We are allowing you to target to a specific cluster. Now you can automate a particular cluster. You can automate a particular cluster to run a cluster autoscaler, and then it can elastically scale from X nodes to Y nodes, just like we have in AKS. It's a very straightforward cluster autoscaler with various tweaks that you can make. And that details I won't go into, but essentially the API server basically takes requests to schedule a job or a pod and then waits. If there is an autoscaler that kicks in, brings up a node, the job is scheduled. Otherwise, it just keeps in waiting. And to answer your question directly, no, we don't schedule jobs across your on-prem clusters and in the cloud or all that. The way I see that evolving is through the promise of Kubernetes Federation that has been in alpha for I don't know how many years, and we hope that we solve it in the open source world. And Kubernetes, a single Kubernetes control plane, is able to access, node pools or cluster of VMs that are across clouds, across regions, whatnot. So we hope that it has evolved that way. But you bring up an important point. Maybe we will have it. We don't know. It's if that's something that customers really value, the ability to schedule seamlessly across all these assets they have. Sure, we'll take a stab at it.
Yeah, that's interesting too, Saurya. So I guess like to Cynthia's point, would you say that you typically see customers who have dedicated clusters specifically for the machine learning jobs? Like they're not necessarily going to be like, oh, the machine learning jobs get these namespaces within another cluster. I would assume that typically technically they could, but maybe like just more curious, do they typically dedicate an entire cluster to, Azure machine learning, or have you seen it work different ways?
So it's very different from organization to organization. Of all the AKS customers that I spent years and years with, a common pattern in dev test looked like, hey, I give out namespaces. Because remember, you create, an IT operator creates 10 clusters, there are 10 control planes to monitor. So they kind of try to have a good balance between physical clusters and logical isolations of clusters. So they usually hand out namespaces in dev test scenarios. The production units are, we actually advise them to keep them separate, because otherwise if you have a single large cluster where you're doing everything, it becomes a single point of failure. So it's a good balance. It is possible that, in machine learning, because you're using specialized queues, you would dedicate clusters for machine learning. But
yeah, makes sense, or like at least a specific node pool. Yeah, I guess that's a good point. Okay, so in terms of the integration with Azure Arc, or at least you mentioned Azure Arc, will we expect it to look like something like, how we have data services now, or Arc for, Kubernetes? Will it look like an actual like bring down Azure machine learning checkbox? Like,
Yep. It will be already in the portal. So if you are to deploy, so we are built on top of Azure Arc for Kubernetes. So you got a cluster, you installed Azure Arc bits. That's how it gets the Azure Resource Manager ID. Now what we are going and deploying is a bunch of Helm charts that a PyTorch, TensorFlow, open source operators. And just set it up so Azure Machine Learning can talk to it and transform these jobs into native Kubernetes jobs and run them. Azure Portal today only allows you to manage these agents that are deployed. Azure Machine Learning or Policy, or you just have to you can manage their lifecycle, upgrade or delete them. Create is coming later.
Okay, interesting, awesome. And then the last thing I had was just with, like, I know Azure Machine Learning Studio, like I haven't played around with machine learning in a while. Does that fit in anywhere in this story, or not really? Just totally separate?
Yep. It's totally integrated. So Azure Machine Learning Studio is the place where data scientists go to take a look at all the compute resources they have. This is where they have their data sets, experiments, pipelines, the central location. So we have a UI integration there. I have multiple videos I can show where you can basically select a dropdown, select a Kubernetes cluster, attach it. An entire cluster, the default namespace or a specific namespace. We've provided, configurations for that. Also, you can do that, attach it, and you're all set to run your training job. So yes, it is fully integrated with the portal studio.
Awesome. Cool. Any other questions from anyone else, or sorry, just anything that y'all are working on that you want to share, or just updates, announcements? We'll make sure that we link everything in the show notes that we've referenced today, but kind of give an opportunity for everyone to kind of get in a last question or a last thought.
No, I'm good. I just shared all that I had to. There's more coming. We'll make announcements and we'll come talk to you guys.
Awesome. Well, thanks so much for being on the show today. We really appreciate your time. It was a great one. So I'll stop the recording now and say bye to everyone listening and hope to see you next time.
Okay. Thank you.
Thanks, everyone.
Thanks all.